So let's talk about the IUPAC rules for naming alcohols. So first of all, the parent chain alkane containing the OH group, that's the hydroxyl group, is named by replacing the E on the alkane with an OL. This makes it an alcohol. So let's simply illustrate this with an example. For instance, I have this CH3, CH3. Alright, I have 1, 2, 3, 4, 5, 6. So this is a hexane, which is an alkane. Now, so if I have this with an OH here, I'll simply name this by replacing the E here with an OL. So I'll go ahead and name this as hexanol. Now notice that I've replaced this E with an OL. So this indicates that there is a hydroxy group in this compound. Now, what's the position of this hydroxy group? That's 1, 2. So the hydroxy group is at position 2. I'll simply go ahead and add 2 here. So this compound becomes 2-hexanol. Alright, the second rule actually explains this more. The second rule says the position of the OH group is indicated with the lowest possible number. Now notice that from this example, I did not count from here 1, 2, 3, 4, 5, 6. Now if I had counted from 1, 2, 3, 4, 5, 6, now this would have been 5-hexanol, but due to the fact that I need to assign the lowest possible number to the OH group, so I have to start from here and I count 1, 2, 3, 4, 5, and 6. So this becomes 2-hexanol. So the third rule says the position of multiple hydroxy groups are allocated the lowest possible numbers and then named by adding the suffix diol, triol, tetraol, and so on. So if, for instance, I have 1, 2, 3, I have this, okay, let's say I have CH3 here, and then from here I have OH. From here too, I still have OH, and then I have CH3. Now with this, if I want to name this compound, if I count from here, I'll have a lower number to assign to these hydroxyl groups. So I'll simply count from this side so that I'll have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the alkane group here is a nonane. So if I should write this, I'll write nonane Now this is at position 3 and 4. 3, 4. Then I'll add how many alcohol groups? Just 2. So I'll have diol. Assuming I had 3 of these, it would have been triol, and then 4 is tetraol, and so on. So this is how I'll simply name this compound. So let's go ahead and see the next rule. Alright, so the next rule says, in the presence of functional groups of higher priority, the prefix hydroxyl is attached to the parent name with the lowest possible number to show the position of the OH group. So, for instance, if I have this compound, so this will be OH, and this will be O, and then this will be OH, and this will be CH3. Alright, so if I have this, I'll notice that I have a carboxylic acid group here. At this point, this is a carboxylic acid group. So if I want to name this compound, I know that the carboxylic acid is a functional group of higher priority than the alcohol group. So I have to consider the carboxylic acid group first. So with this, I'll simply go ahead and name this 1, and then 2, and then 3. So this is the carbon 1, this is carbon 2, and this is carbon 3, where I have this to be my carboxylic acid, and then this is my carbon 2 attached to the alcohol group. So I'll simply name this as hydroxy, and it will no longer take the form of an OL. So I'll simply name it hydroxy. So this is hydroxy, but it is at the position of carbon 2, so I'll simply call it 2-hydroxy. And then what chain is this? What organic compound is this? This is 1, 2, 3. That's prop, right? And then this is a carboxylic acid, that's propanoic acid. So I'll go ahead and name this 2-hydroxy propanoic acid. So that is it about that. So this is how we can simply go ahead and name our alcohol groups, or our alcohol functional groups, following the IUPAC nomenclature. So next we'll consider the IUPAC rules for naming alkoxy.